Hi, my name is Uniservo, and I love ECL. What's he talking about, ECL? Well, ECL is emitter-coupled logic. It's one of those logic families in electronics that you really don't hear about anymore. But it was kind of the king back in the 70s and 80s. If you wanted speed, if you were designing a supercomputer, if you were designing some test equipment that just dealt with incredibly fast timings, you needed ECL. Of course, these days, CMOS is kind of stomped and ate its lunch actually a long time ago. And ECL is essentially dead. I don't know if anyone actually even still uses it. But in any case, whenever I get a board or whatever, some pile of chips, I always pull out the ECL because I love the stuff. And there is a point to this video other than me talking about how great ECL is, because it's pretty great. It's actually, the designers at Motorola and Fairchild, especially Fairchild, I think, put a lot of thought into how to make chips that actually are good to use, or easy to use. You follow their rules and everything works out fine. Yes, you're dealing with maybe nanosecond delay, propagation delays back in the late 70s, which TTL couldn't even come close to that. And you have to deal with all sorts of things you don't need to worry about, like the length of wires and things like that. But if you followed their rules, the manufacturer's rules, and they had a book for that, it was actually a pretty good family to work in. Of course, no one works like that anymore. Everything is pretty much a big gate array or FPGAs. No one really uses the individual gates and building blocks like flip-flops and things like that. Well, ECL, let's take a look at some. There's a point to this video, and it involves this card. Let me see if I can get close here. And yeah, this is fooling with my camera. Here we have some 10K ECL, pretty standard stuff. Ceramic packages, beautiful Hitachi. Hitachi always did a really great job making their chips look really good. Anyway, this is a board out of some Anritsu test equipment. Now, Anritsu is sort of like the poor man's Japanese HP. And apparently they used to basically buy designs from HP or parts of designs. When HP had kind of had their way with the design, they made their product, got out the door. Apparently they would sell bits and pieces to Anritsu, and then Anritsu would not really clone the machines, but they would. If you look hard, there's clearly HP blood here. And yes, it was all done above board. No one was stealing anything. Anyway, I had some smashed up Anritsu test equipment, optical time domain reflectometers and things like that. And it was smashed up because, well, the bean counters at some company, I don't even know where, bean counters had to get it off the books, get this pile of stuff off the books, and make sure the employees couldn't use them. So yes, precision alignment tools called sledgehammers were used, but I got to scrap the stuff, hey. And so this board here, I'm not going to scrap it because it's got ECL. Whenever I find ECL on boards and stuff like that, I tend to keep it. 10K is actually pretty common. The older families like MECL 1, 2, and 3, those were Motorola. So is 10K actually. That stuff is just hard to find, especially MECL 1, because it's almost always in little cans. I've got some somewhere around here, but I can't find it. And some of the better stuff, the faster family was 100K, and we've got some 100K here. Let me get my pointer here. And here we got more from this Anritsu stuff. Here's some 100K. Oh, look at those wonderful things. Oh, these ECL was really, really, really expensive. When I was designing in ECL, this 100K, hey, look at it. Look at your 7400 series TTL, a standard four a quad NAND. What did that cost? Like 29 cents or something like that. The equivalent in 100K ECL was about $7 a chip. Yeah. And oh yeah, I should say that sometimes you would find 100K in these nifty flat packs. This is actually out of some tech equipment, and I don't know what, but it sort of looks logic analyzer-y. But yeah, that's early surface mount 10K there. Anyway, ramble. The point of this video is not to well, mourn the loss of ECL because, well, no one uses it. Also because you could probably fry an egg on those 100K chips. They suck power like you wouldn't believe. I need some help. Anyway, this Anritsu, I forget which one of the bits of equipment this board came out of. I don't think it was one of the TDRs. It may have been one of the message generators, or there was also a bit error rate machine. Weird little white chips I can't find data on, and I am asking you, YouTube, my subscribers, anyone else on YouTube, if they know what these are. Let's see if we can zoom up on these guys here. Here we go. All right, so they're upside down. Let me flip that around here so you can actually see. There we go. What are these? They're NEC, obviously. They have the logo. They certainly kind of have the ECL vibe, being, well, near some other ECL, and there's an awful lot of termination resistors kicking around, which also kind of screams ECL, because ECL, you have to treat everything like a transmission line. Everything gets a termination resistor. That's just the way you had to do it. But what are these? B606. I think there's a B603 somewhere in here. 601. I don't have an NEC book from, well, this is what, mid-80s, I guess? Yeah, 84, 85. I have no data. I can't find data. I looked on Google and couldn't find any data. What are these things? I'm kind of assuming that these are actually... well, NEC used that weird prefix of the mu, mu P, you know, it looks like UP. Apparently that stands for micropack. And then B was the next letter, and here they show up. The B's actually show up. B's were used for flat packs, and so these are chip number 602, I guess, and 604, and 606, and all that. What are these things? I'm looking for data, because if there's some sort of neat form of ECL that I don't know about, hey, that's pretty cool. Oh, I should say one thing about this. Let me see if I can do this here. All right. Here is the underside of that same location on the board. Get my pointy here. Here you can see the where the flat packs are. Each one of them has a solder blob. I'm kind of assuming that there's a stud that goes through the board, hits the bottom of the chip. Maybe it's part of the package. Maybe it's just a rivet, a copper rivet. I don't know. But clearly these chips ran hot. Well, for one, they're white, which probably means they're beryllium oxide. But they have these sort of not really heat sink. It's actually using the board as a heat sink. But I don't know. Heat pipes? I don't know. Whatever they are. It's apparently some way to draw heat away from the package and onto the board. And you can see then you've got all these ground planes and such like that. So what are these things? That's the point of this video, is if any of you guys, maybe if some of my Japanese viewers, which I think I have a few of, if you guys know what these chips are, tiny little flatbacks. You can see there's a normal dip. Here are the flatbacks. What are these? Yeah, what are these is the basic question. So, yeah, hey, if you know, leave a comment. Some other neato stuff on this board, too. Let's zoom out here. I mean, I really like Japanese electronics. They do a good job. But yeah, we got these small, weird little. Let's see if we, yeah, I don't know what that is either. I'm kind of guessing that's some sort of power transistor, UHF power transistor. I don't know. Who knows? Um, anyway, yeah, leave a comment or hey, if you've got data on this stuff, let me know and send me an email and with the data sheets or something like that. I'd love to know. So yeah, that's about that. Hope you like the video. Um, yeah, do all the normal things, subscribe, hit bells and stuff like that. Comment. And hey, if you're interested in these videos and you want to see more, why not throw in a buck? I do have a Patreon account. I'll leave a link. And as usual, many thanks to my current patrons. And once again, I've forgotten the list. However, I don't think there's been any additions, nor deletions, which is good. So sorry. Next time I'll get your names out. Those, of course, that want to be named. Some guys don't like to be named. But yeah, thank you to my patrons. And all right, if you have any news on these little white chips, I'd love to hear from it. And hey, I'll see you around. Bye-bye.